here, we're going to try to demonstrate using the light from the projector itself, the phases of the moon. There I am, here we are. Welcome. All right, so we're going to sort of imagine that my eyes are like eyes here on Earth, and this guy right here is the moon. Right? The light from the projector is the sunlight. Okay, so why does the moon go through phases? You know, sometimes younger students will have a misconception, and it's like, oh, it's the Earth's shadow, right? Well, so if the Earth is casting a shadow on the moon, what's that called? A lunar eclipse, which there will be one in a couple of months. I think in June it's going to be a total lunar eclipse. So the answer to the question of why the moon goes through phases is due to the relative position of the Earth, the moon, and the sun. Okay, the relative position of sort of all of them. So if my eyes are here on Earth and I'm looking at the moon, think about from my perspective now. So the sunlight is hitting the far side of the moon, not the dark side of the moon, right? That's the far side of the moon because there's going to be one face of the moon that's always sort of facing towards Earth. So if the moon is here relative to my perspective, I see a new moon. All I see is sort of the blackness of this side of the moon, right? Tonight, the moon is going to be right here, 1/4 of the way through its entire revolution around the Earth, okay? So we call it a quarter moon. Think about what this looks like now from my perspective. This part of the moon is lit up by the sunlight, right? So I'm only seeing sort of this half of it. It's not called a half moon, though. It's called a quarter moon. When you see half the moon lit up, that's a quarter moon because it's 1/4 of the way through its cycle. So I'm seeing this, you know, half of the moon, 1/4. So that's the moon is waxing from new to full. So this would be a waxing moon like this, right? And so when it's a crescent, you can just sort of see barely any of it lit up here. And so if you do this with, you know, a light source and hold up sort of a sphere, you can actually see the shapes of a crescent moon, a quarter moon. If I go all the way around to here now, okay, from my perspective, I see the entire surface of the moon lit up. This would be a full moon, right? And so this is when we can actually get a lunar eclipse if the Earth perfectly sort of blocks out the moon, right? That'd be a lunar eclipse. A solar eclipse can only happen here during a new moon. If the moon perfectly blocks out the sunlight, then that's a total solar eclipse. Okay? So this would be half a month from a new moon. We got a full moon, right? Where the entire face of the moon is lit up from my perspective here on Earth. The last quarter moon is where now the other half of the moon is lit up, right? Because again, if we're 3/4 of the way through the cycle, now we can see this side of the moon is lit up facing the sun. This side is in darkness. And so it looks like only half the moon is lit up, but it's a 3/4 moon, right? It's the last quarter. The last quarter, the moon wanes from full to new, right? So we have the moon is waxing crescent, quarter moon. We call it gibbous moon, nearly full. So this would be like a waxing gibbous moon. There would be a full moon. And then we have a waning gibbous moon. We have a last quarter moon. We have a waning crescent moon and a new moon again. So that's how you can sort of visualize the phases of the moon.
So why is it that it's called gibbous?
Gibbous means humpback. And so it looks like the moon is like a humpback. You know, it's not quite full, but it's got like a hump there. So it's from the Latin, I think. I don't know exactly the translation, but very researchable question. You could